Picture this, the year is 1950. Alan Turing, a brilliant British mathematician, proposes the question, can machines think? This was the spark that ignited the dawn of artificial intelligence. Turing's innovative mind birthed the concept of the Turing test, a challenge for a machine to exhibit intelligent behavior indistinguishable from that of a human. This test was more than just an idea, it was a blueprint for the future of AI. Fast forward 6 years to the Dartmouth Workshop, a gathering of minds in 1956. This event, packed with pioneers like John McCarthy and Marvin Minsky, is widely recognized as the official birthplace of AI. A hotbed of innovation, the workshop brought together some of the greatest minds of the time to focus on the potential and promise of artificial intelligence. So by the end of the 1950s, the foundation of AI had been firmly laid, opening the door for the exciting developments to come. As the 1970s approached, AI hit its first major roadblock, commonly referred to as the AI winter. This period was characterized by a significant reduction in funding and interest in AI research. The grand promises of AI pioneers in the 1950s and 60s had not been fulfilled. The lack of substantial progress, coupled with the high expectations, led to disillusionment. Several factors contributed to this AI winter. Foremost among them was the lack of computing power. The machines at that time were not powerful enough to handle the complex computations required by AI algorithms. This severely limited the practical applications of AI. Another major issue was the lack of a solid theoretical foundation. Early AI research was based more on optimistic speculation than on scientific rigor. This led to overly ambitious predictions that couldn't be met, resulting in a loss of credibility and funding. But every winter is followed by spring, and the same was true for AI. The 1980s saw a revival in the field, largely thanks to the advent of expert systems. These were computer systems that emulated the decision-making ability of a human expert. They were designed to solve complex problems by reasoning about knowledge, represented mainly as if-then rules. One of the key figures in this revival was Edward Feigenbaum. Known as the father of expert systems, Feigenbaum and his team at Stanford University developed Dendrel, one of the earliest expert systems. Dendrel was designed to infer the molecular structure of organic compounds, and it showed that AI could have practical applications. The success of expert systems revived interest and funding in AI research. They demonstrated that AI could be used to solve real-world problems, thus proving its practical value. The AI winter had been a setback, but it also served as a reality check. It helped the AI community realize the importance of solid theoretical foundations and practical applications. The AI winter was a period of disappointment, but it set the stage for a major comeback. Fast forward to the 1990s, and we see the resurgence of AI, largely thanks to a new approach, machine learning. This was a significant shift from the earlier rule-based systems that required programmers to manually input every rule a computer needed to follow. Machine learning turned this concept on its head, with systems designed to learn and improve from experience, much like the human brain. This shift was driven by pioneers such as Geoffrey Hinton, Yann LeCun, and Yoshua Bengio. These remarkable individuals, often referred to as the godfathers of AI, made groundbreaking contributions to the field of machine learning. Hinton, for instance, was instrumental in the development of a concept called backpropagation, a cornerstone of modern neural networks. LeCun, on the other hand, was a key figure in the advancement of convolutional neural networks, which are pivotal in image and video processing tasks today. Bengio's work focused on deep learning, a subset of machine learning that employs complex neural networks to mimic human thought processes. Speaking of neural networks, these have been significant in the rise of machine learning. Inspired by the biological structure of the human brain, neural networks consist of interconnected layers of nodes or neurons. Each neuron processes information it receives and passes it on to the next layer. This allows for complex, layered decision-making, much like how we humans think and make decisions. Deep learning, an offshoot of machine learning, takes this even further. It uses neural networks with many layers, hence the term deep, to model high-level abstractions in data. This has proven incredibly effective in tasks such as image and speech recognition and natural language processing. The rise of machine learning not only revived AI, but set it on a path to become a part of our everyday lives. It's the driving force behind everything from your recommended Netflix shows to Google's search algorithms, and even self-driving cars. So, the next time you ask Siri a question, remember, you have machine learning to thank for it. Now, in the 21st century, AI is transforming our world in ways we could have only imagined. The current state of AI is both fascinating and awe-inspiring. From healthcare to education, transportation to entertainment, AI is becoming an integral part of our daily lives. It's streamlining processes, enhancing productivity, and opening up a world of possibilities. Consider the revolutionary strides made by tech giants like Google, Amazon, and IBM. Google's DeepMind is leading the way in AI research, pushing the boundaries of what's possible. Amazon, on the other hand, uses AI to understand consumer behavior, optimizing their services and products to meet customer needs. IBM's Watson is another game changer, using AI to revolutionize industries from healthcare to finance. But the story of AI isn't just about big tech companies. It's about how this incredible technology is being used to solve complex problems that touch every corner of our world. For instance, AI is being used to combat climate change, analyzing vast amounts of data to predict and mitigate its effects. It's helping doctors to diagnose diseases earlier and with greater accuracy. The potential of AI can't be overstated. It's not just about creating intelligent machines. It's about augmenting our capabilities, improving our world, and tackling the toughest challenges of our time. It's about making the impossible possible. The future of AI promises even more exciting developments. We're on the brink of an era where AI will become even more integrated into our lives. It will continue to evolve, learn, and grow, shaping our future in ways we're just starting to understand. So from Turing's initial question in the 1950s to today's advanced AI technologies, this journey has been nothing short of extraordinary. But remember, we're just getting started. The true potential of AI is still unfolding.